In the previous video, we were looking at some examples where the rent for an apartment changed from year to year, so we thought of it as a function of the year. And at least the way this is spelled out here, we've got the rent for a few different years, 2017 through 2021. So maybe the apartment didn't exist back in 1955. Maybe it's not going to exist in 2055. Maybe it will still be around 10 years from now, but we don't know yet what the rent is going to be in that year. So the way it's specified here, this only applies to the years 2017 through 2021. So those are the specific numbers that show up as possibilities for the year, possibilities for the first coordinate of the pairs that make up this function. And then the possibilities for the rent, the second coordinate, are the numbers on this list. Now these two variables, we can refer to them as the independent variable and the dependent variable. The dependent variable is the one that depends on the other one. So usually the independent variable is listed first, and then the dependent variable that's a function of the independent variable is listed second. So if we've got y as a function of x, the y is the dependent variable because it depends on x, and the x is the independent variable. And with the ordered pairs, the independent variable is listed first, and then the dependent variable, the thing that depends on that, is listed second. And some terminology here, the domain of a function is the set of all possible values for the independent variable. Remember, that's the first number in the ordered pairs. So it's all the numbers that show up as the first number in one of those pairs of numbers. And the range of a function is the set of all possible values for the dependent variable, the second number. So in the example we were just looking at, the domain consisted of this set of numbers here, 17, 18, sorry, that was supposed to be an 18, 19, 20, and 21. And the range is the set of all of the second numbers, 800, 950, 1,100, 1,250, and 1,400. Now let's look at an example of function notation. In this example, a catering company charges $200 plus $8 per person to cater a meal. So if you want them to come and cater your meal, your dinner or whatever it is, and you want to know how much they're going to charge you for that, it's going to be $200 plus $8 per person. So it depends on the number of people. It's a function of the number of people. And here's a formula that shows exactly how that's calculated. X stands for the number of people. You take 200 plus 8 times X to get the charge to cater the meal for X number of people. And we call that C of X. So that's read C of X. It's a function of the number of people. So C is the function, the catering charge, and it's a function of X, the number of people. So if I ask, okay, what's the cost for to cater a meal for 40 people? The short way of asking that is, what is C of 40? What's the charge if I put in 40 for the number of people? So if I take this formula and do to 40 what the formula says to do to X, that means I'm calculating 200 plus 8 times 40. So 8 times 40 would be 320. 200 plus 320 would be 520. So the answer is $520. What's the cost to cater a meal for 10 people? That is, what is C of 10? So if I put in 10 for X, 200 plus 8 times 10 is 280. What about for 300 people? C of 300 would be 200 plus 8 times 300, which, when you do the calculations, works out to $2,600. And what about the domain? Remember, the domain is the set of all possible values for the independent variable. Here, that would be the number that we're plugging in for x, the number of people. Now, this formula would work for any number. We can do the calculations on any number. Positive, negative, fractional, doesn't matter how big or how small. We can take any number and multiply it by 8 and add 200. So from a calculation standpoint, the domain here would be all real numbers. But from a practical standpoint, if x stands for how many people are at this meal, there are certain possibilities that don't make sense for that. It probably doesn't make sense for x to be a negative number, or for x to be a fraction. Like we're talking about a meal for 16.25 people. And there may be some upper limit on the number of people that they can cater a meal for. So if you said, okay, I want you to cater a meal for 65,000 people, or 65 million people, and they say, wait a minute, we can't do that. Maybe there's some upper limit. Maybe there's some lower limit. Maybe they won't cater a meal for just 1 or 2 people. So whatever the limitations on x are, that might specify what the domain is. So if the number of people has to be a whole number from 1 up to, say, 600, then the domain would be the set of all whole numbers from 1 to 600. Some people like to think of functions as being like a machine that you put numbers into and get numbers out of. So if you take your function machine and put in a number for the input, the machine does whatever it does to that number and spits out a number for the output. So the machine we were just looking at, you plug in a number and out comes 200 plus 8 times that number. So to really be a function, it only accepts numbers from the domain of the function, whatever that is. And for each input, there's exactly one output. Now, it might be repeated for different inputs. You might get the same output from 2 different inputs. But you can't have the same input give you 2 different outputs. So I can't throw the number 17 into the machine and get out 22, and then later somebody else comes along and throws the number 17 into the same machine and gets a different number out. It's always going to do the same thing to the same input. Let's practice some more function evaluation. So this function doesn't stand for anything in particular. It's just f of x equals 5x minus 1. This is a function that takes whatever you give it as the input and then gives you as the output 5 times that number minus 1. So to find f of 3, that means find what the output is when the input is 3. What does this function do when we give it 3? It gives us 5 times 3 minus 1. So 5 times 3 is 15, minus 1 is 14. What is f of 10? That would be 5 times 10 minus 1. So that would be 50 minus 1, or 49. What about f of 0? 5 times 0 minus 1 would be 0 minus 1, which would be negative 1. What about f of negative 1? That would be 5 times negative 1 minus 1, so negative 5 minus 1 is negative 6. What about f of w? So here we're putting w in place of x, and we get 5 times w minus 1. And that's it. That's just the answer. That's what comes out. F of smiley face would be 5 times smiley face minus 1. So whatever we put in the parentheses in place of the x, that goes in place of the x in the formula. the function does to that thing what it's doing to x here. So the x is like a placeholder that gets replaced by whatever the input is. F of b plus 2 would be 5 times b plus 2 minus 1. And we can simplify that because 5 times b plus 2 would be 5b plus 10, and then 5b plus 10 minus 1 simplifies to 5b plus 9. So if our input is b plus 2, the output is 5b plus 9. What if the input is 2n? Then we get 5 times 2n minus 1, which would be 10n minus 1. How about another function? This one I'm using the identifying label g. So g takes whatever you give it for x and outputs x squared plus 2x plus 10. So to find g of 3, we got to calculate 3 squared plus 2 times 3 plus 10. So 3 squared is 9, 2 times 3 is 6. When we add 9 plus 6 plus 10, we get 25. What's g of 0? Well, that would be 0 squared plus 2 times 0 plus 10, which works out to be just 10. What about g of negative 2? Well, that would be negative 2 squared plus 2 times negative 2 plus 10. So positive 4 plus negative 4 plus 10, that works out to be 10. Notice, by the way, it is possible to put in two different numbers for input and get the same output. So that can happen with a function. Some functions can do that, some can't. A function where that never happens is called a one-to-one function. And that's something we'll talk about in a later section. So right now, that's kind of a preview, what's coming up later on in the chapter. So if there's any way of putting in two different numbers for input and getting the same thing for output, we say that's not a one-to-one function. Okay, let's try another example of a function. This is function h that takes a number, whatever we give it for x, and outputs 1 over that number plus 10. So h of 10 would be 1 over 10 plus 10. We're putting 10 in for x, so we get 1 over 10 plus 10. That would be 1 over 20, which we could just leave in fractional form, or 1 divided by 20 in decimal form would be 0.05. What about h of 0? Well, that would be 1 over 0 plus 10, which would be 1/10, or 0.10 in decimal form. H of negative 3 would be 1 over negative 3 plus 10, 1/7. H of negative 10 would be 1 over negative 10 plus 10, 1 over 0, but we can't do 1 over 0, that's undefined. You can't divide by 0. So this is a function where if we try to put negative 10 in for the input, we don't get an output. The function doesn't work on that particular input. So negative 10 is not part of the domain of this function. We can put in any other number and it works just fine. It gives us whatever it gives us. But if we try to put in negative 10, it just coughs and smoke comes out and the function breaks down. So the domain of this function, the set of numbers that we are allowed to plug in, is everything except negative 10. So if I ask you, what is the domain of this function? The answer would be all real numbers except negative 10. So I'm going to end this video here, but in the next video, I'll talk about how you take a function and figure out what the domain of that function would be.